I got my first computer when I was 6 years old.
I was really young.
6th grade, somebody showed me 2 lines of BASIC and I fell in love with this idea.
My thing is music. I want to build the ultimate interactive music system.
I'm actually trained as a oil painter and traditional artist.
My parents are both circus artists. Unity, it's the sum of all these parts.
First time I heard of Unity, a company with a vision, it was technology guided by that vision that actually worked and delivered on its promise. And I thought, I need to be part of that.
And I pretty quickly got the democratization and the openness, and I saw it as the future.
To make creation accessible, the first thing you need to think about is removing roadblocks.
The space was not approachable and unaffordable.
Oh, I have to write a rendering engine. Oh, I have to write an animation system. Oh, I have to figure these things out. Oh, there's a lot of math. We've taken care of all of that.
Solving hard problems, I feel like, is kind of the engine that makes it all go.
If you have to worry about nothing else than what you're actually focusing on, what you're actually passionate about, then there's no way you are not going to succeed.
Not just provide them with the very sophisticated piece of software, but also provide the support that is required to, sustain in that industry.
Unity believes that everyone has the right to create.
Whether it's indies, AAA companies.
You don't want a barrier between you and exploration.
A couple of kids in Cambodia could use software like Unity to produce the #1 mobile game for many years.
So you see Unity being used everywhere.
A lot of people are coming and seeing us and say thank you.
People can quit their day jobs and focus on what they're truly passionate about.
Our tool enables them to do that. I've never seen that anywhere else.
I've been working at Microsoft, Amazon, Uber. Unity is a different place. Yeah.
Coming from Indonesia.
A city called Zonguldak.
Maryville, Tennessee.
Plymouth in England.
København, Denmark.
Roseville, California.
Горнозаводск, Россия.
À Montréal, au Canada.
With technology, it democratizes the world in a way.
I'm an enabler. But in the best possible sense, in that I want to enable people to make the things that they dream about.
Creators are the pace setters, the dreamers, those with an imagination, and we are here to support them because we think the world's a fundamentally better place with more creators in it.
Please welcome Unity's CEO, John Riccitiello.
So, good evening, everybody, and welcome to Unity's keynote for GDC 2018. Now, at Unity, we think a lot about how we can best serve our developers. And that's because you, the developer, are doing all the creating. You're doing all the innovating, and you're the one driving the industry we love so much as a whole. Now, at Unity, I think you know, we talk a lot about our principles, but we try to stay focused on these particular ideas, and you can see them up here on the screen behind me. Democratization, solving hard problems, and enabling success. But there's a philosophy that lives behind these. And the first point is we do fundamentally believe the world is a better place with more creators in it. Now, we love consumers, we love gamers, and there's 3 billion of them out there, that's fantastic. But our heart beats to the rhythm of the developer. We're really on their side. And we know how hard it is to be a developer. The investment in time, ingenuity, and craft that goes into making a great game. And we know the odds are stacked against the developer. It's hard to create a great game. There's huge competition. And the platform companies don't make it easy. They don't make it easy for discovery, for distribution, any of it. And we think our place in the world is to stand with and for developers. Think of us as an 800-person technology team, engine development team. It's your engine development team that's here to make sure that you can get to each platform quickly, easily, with leading-edge technology. We're a business team that's here to enable your better revenue and your better outcomes, so you can focus on the content, on the game mechanics, and the player experience. Now, we're not focused at Unity on making games. We're here to solve the hard problems so you can make the games. We sit at the center of an ecosystem. And as I said, we're proud to stand with you and for you in the world that we all want to see come together. So I want to bring it back to you now, the developer, and show a little bit of the amazing impact you've had in 2017. Why don't we roll the video?
Okay, now.
For everybody over here, I promise, the video worked on this side of the room too earlier today. But I guess I'm a CEO and I thought I needed like my own private stage space. You know how those egos get going. But now, think about this. 69% of the games and products built in the world were built by you, the Unity developer. 74% of everything made for HTC Vive. 87% of everything for Gear, and 91% of everything for the HoloLens. That's absolutely unbelievable. And perhaps the most unbelievable of all is that half, more than half actually, of all the mobile games built in the world were built by you, the Unity developer. I mean, that's freaking amazing. Now, we live at a time when there's all sorts of theories about what creates employment. And my answer is, it's you. And here's a really interesting slide. It's some data that I hadn't expected and wasn't really looking for. But this is LinkedIn. All the job search all over the world. They rank each of the jobs in terms of what is the most prevalent and the second most common search and the third most common search, what people are looking for. And of course, there's a lot of tech jobs. We're in the middle of a technology revolution of biblical proportions. But look at it. I mean, you'd expect it. I mean, machine learning engineering is hot, and data scientists are hot. Sales development, folks are hot. But what do you notice about position number 7? It's the only entry in the top 10 that has a company's name associated with it. The others are broad descriptions. This is a very specific description. And it shows that you, the Unity developer, are hiring like crazy. And it shows the Unity developer actually probably the best solve for the world's economic woes of anything that's out there. So with that grand thought that you're solving the world's economic woes, I'd like to shift gears for a moment and turn to what we'd like to talk to you about tonight. Now, you're going to hear from most of the people you saw in that video, but you're going to hear from the best and brightest at Unity. You'll hear from Brett and Isabel what's going on in 2018. Brett's going to take you through our roadmap, the key products coming out in 2018 through the balance of the year. And Isabel's going to share what the dreamers and creators are doing with Unity, what they've been up to and what's coming out. Now, they're going to be followed by Danny Lang. Danny's going to talk about machine learning and AI, and how AI can be trained not only to monetize your games better, but make them play better and more tailored around an individual gamer's experience. Yes, you can use AI for that. Natalia, Lucas, Mike, and Adam are going to demonstrate the next level rendering and what we're doing with the Scriptable rendered pipeline to allow you to make achingly beautiful products. And finally, Joakim and Ralph are going to share the future of Unity, the incredible impact on performance and scale made possible with the Entity Component System, and some small runtimes are going to change everything in the way consumers launch, how they're built, and how they're consumed by consumers around the world. All of these are the next steps allowing you to use the most performant engine to make the best games possible. All you need now is to understand a little bit more on what can be possible, and with that, we'll show you a video to give you a better sense of what that is. Thank you.
Please welcome the head of Made with Unity, Isabel Riva.
We are so impressed by the talent and ingenuity of the community. The art styles are so versatile. There's hand-drawn games like Cuphead and super realistic games like GTFO, and we aren't the only ones noticing this creativity. Brands are impressed. They're coming to us asking to build bridges with the indie community, and we love making that connection for them. In fact, we have, in that vein, an announcement to make today. It's a challenge put together by Universal, Microsoft, Intel, and Unity, inviting you to design a PC game based on an iconic brand. And get this, you can pick from Back to the Future, Turok, Battlestar Galactica, Voltron, Legendary Defender, or my personal favorite, Jaws. You stand to win $250,000 worth of cash prizes and a contract with Universal Studios. We're calling it the Universal Game Dev Challenge. The work will be judged by these industry veterans: Bob Gale, co-creator of Back to the Future; Kate Edwards, former executive director of the IGDA; Dean Takahashi, lead writer for GamesBeat; and Lauren Montgomery, co-executive producer of DreamWorks TV and showrunner of Voltron. So starting today, you have exactly 1 month to submit your winning game idea in the form of a design doc to Unity Connect. So track down some teammates and get started. If that wasn't enough of an opportunity for you, there's one more. This one's coming direct from a veteran game maker who is building his next game in Unity.
I'm Will Wright, game designer, responsible for many games you might be familiar with, including SimCity, The Sims, and Spore. The new game I'm working on is called Proxy, a game of self-discovery, where we actually uncover memories from your past. To do this, we partnered with Unity to announce a contest to find an artist that can help us bring this to life, to manifest these memories in a cool and unique way. You can enter this contest at Unity Connect, and to that artist, and I know you're out there, I look forward to meeting you.
Please welcome Vice President of AI and Machine Learning, Danny Lai.
Thank you. Good evening. You know, at Unity we are committed to democratizing development. And in an effort to provide you with the very best tools for game creation, we are making machine learning available to you all. We are committed to lowering the barriers of entry so that you can use machine learning as an integral part of your game development. Machine learning, we know that it can be expensive, it can be difficult to master, and it can be time-consuming. But it can also make your games and your game development easier, and in particular, make your games more fun to play for your players. As developers, with machine learning, we no longer have to program every solution, every NPC, every permutation of what a person how a person may interact with a game. We can make systems learn instead. Like people learn from the environment and respond to it, we can make systems learn the same way. In our goal of democratizing machine learning, we have created ML agents. Unity ML agents is an open source AI toolkit that helps developers and researchers train agents in realistic, complex scenarios with a very realistic 3D environment from the Unity engine. In our latest release of ML Agents .3, we have many new features, but there's one very important feature called imitation learning. With imitation learning, a system can learn from real people playing, and it can be trained to adjust to your players. Instead of building an NPC through conventional code, writing lines and lines of C#, you can create it through imitation learning, which will deal with your game environment in a much more organic manner. It will not play perfectly like a robot, but rather imperfectly like a real player. The most exciting part of imitation learning in ML agents is that training happens in real time. So let me show you a demonstration featuring assets from Cybernetic Walrus and their soon-to-be released game, Anti-Graviator, a futuristic racing game. In a racing game, you neither want the NPC vehicles to lose too quickly, nor do you want them to leave your players in the dust. The appropriate level of challenge is what keeps the game engaging. This is a beautiful 3D game. We're going to slow it down a bit so that you can see how the machine is being trained here. When I slow it down, it will lose some of its magic, but I want you to see clearly what is happening when we are training. You will see a human on your left side, and you will see the agent on the right side. Let's take a look. Early on, you will see that the machine, the agent, is crashing. It's trying over and over while the human is doing really great. It is learning bit from bit, from the human, literally. But look here, after just 25 seconds of real-time training, the agent is actually doing pretty well. It's still wobbly, it's not perfect, while the humans still feed this agent bit by bit training data. And after 5 minutes of training, you will see that the agent is doing really well. The reason that it's doing so well is, of course, that Mike, our evangelist who trained this agent, is actually very good. You may actually say he's a little too good, because if he would have been crashing a little more, the agent would sort of have learned to crash as well. Yeah. Now, machine learning is at the center of everything we do, powering the entire Unity ecosystem. But more than that, machine learning insights allow us to build tools that optimize your games for retention and engagement. We know that more than 50% of the one-star reviews in the Google Play Store mention performance issues, which makes it one of the most important challenges that we can help you solve. As a Unity developer, I can easily develop for iOS and Android. That's simple. But we know there's more to it than that. There's iPhone 10, and there's the Google Pixel 2. There's Samsung Galaxy S7, but there's also an iPhone 6 and a lot of other iPhone models. Yeah? In fact, there are more than 50,000 smartphone models currently in use across the world. It's a lot of phones, a lot of different models. Yeah. So now you're left with two options. One option is to build for the high-end devices and put in all the effects and graphics that you can imagine, but risk crashing on the lower end or older devices. Yeah? You could also, on the other hand, choose to aim for the low-end devices and not really fully execute on your vision for the high-end devices. Yeah? We don't want you to really have to make that choice. There is a better way, and it's called Unity Live Tune. Unity Live Tune optimizes performance settings dynamically for every device in real time. It adjusts the assets, effects, and rendering for each phone model, giving the best possible experience for a player on a given device. Envisio, an independent game studio in Montreal, use Live Tune with their game Roller Coaster Tycoon Touch. Live Tune addressed key performance issues and improved Android players' long-term retention with a whopping 33%. That's actually amazing. Yeah. Thank you. But let's take this a step further. I just discussed improving gameplay at the cohort level of devices, of phone models. Yeah? But what about optimizing for the individual player? The first step we are taking in that direction is IAP Promo. IAP Promo surfaces the best possible in-app promotions to each player based on their game behavior. We know, however, that even if you were to provide each player with the right offering, a lot of players never make an in-app purchase. That content is just not relevant to them. Yeah? That's why we're building algorithms to ensure that we show each player the exact right content at the right moment. It could be a promotion for your other game. It could also be an ad, or it could be that virtual good that that player really needs at that moment. One size does not fit all. I could not buy a pair of shoes and expect them to fit every person in this room. That's impossible, yeah? Games aren't any different. Each person has a combination of hardware, software, skills, and interests that create millions of options. Yeah? We want to give you the tools that make your game accessible for everyone and deeply engaging for every person who plays. Thank you very much.
Please welcome Vice President of Engineering, Brett Bibby.
Good evening, everybody. How's everybody doing tonight? Right on. I have the absolute honor of leading the core R&D team at Unity. And many of these people you can see here on the screen, but actually that's more than 500 super talented men and women, engineers, test engineers, product managers, UX designers, technical artists, technical writers, and more. And together, we have the absolute privilege of being your engine team. The team that provides you with the tools to create content, the tools to integrate with your own tool chains, to assemble, layout, and polish your content and scenes, to code, build, deploy, and help you even operate your games. As your engine team, we are only successful if you're successful. So we are very, very, very grateful for your continued love and support. So from all of engineering, a very, very warm thank you. Thanks for that. As you know, we don't make games ourselves. We live as game developers through you. Internally at Unity, across the company, we celebrate your achievements, and we feel your pain when things don't go so well. To address your needs, this year, we have scheduled 3 releases in the spring, the summer, and the fall, 2018.1, .2, and .3. Today, you're going to see some great new artist tools. You're going to see our brand new great rendering pipelines and supported features. These 2 themes, artist tooling and rendering, is something that we're going to be doing all year. They're going to get a lot of love throughout the year, in addition to our focus on optimizations and performance. Next, we are going to release our industry-leading real-time ray tracing GPU Lightmapper. Also, a new SVG importer, 2D character animation tools, new asset bundle tools, and a lot more. But what you should actually do is decide right now that you're going to join us in Germany, in Berlin, in June, for our Unite event there, and get all of this really great stuff firsthand. Now, later in the year, in the fall, what's coming in 2018.3? I have 2 words for you: nested prefabs. Apparently, a few of the users wanted this feature, so we decided to put it in. So yeah, we'll bring it later in the year. But what could be better than nested prefabs? I mean, should we just shut it all down and go home right now? Well, based on your input, I'm happy to tell you we are introducing long-term supported versions of Unity. The long-term supported versions of Unity will be based on our fall .3 version every year. And then we will continue to release patches and roll-ups of bug fixes with no new functionality, no new features for 24 months, for 2 years beyond the last .3 version. And because we have a LTS version every single year, that means you have 1 year of overlap. So you can upgrade your games and your projects when you're ready, allowing you to keep your games running as long as you want. The 2017 LTS, based on 2017.3, is available now for everyone. Switching gears a bit, I just love new gear, and who doesn't? And I'm kind of in the right job to really love new gear. It's an exciting time in the world of platforms and devices. There's an absolute explosion going on with innovation across the board. With so much innovation happening, it's opening opportunities not just for creators, but for consumers alike. It's also an insane amount of work for creators to support so many devices. At Unity, we think a lot about solving this problem and about giving you the reach that you need to be successful. When important new devices reach the marketplace, we want to ensure we have day one support for you. For pioneers in augmented reality, Unity has partnered with Magic Leap to bring you support for the Magic Leap 1. You can get started developing for the Magic Leap 1 with the Unity Developer Preview that's now available. We also have something to share today from our partnership with Oculus. You now have the ability to build directly for the Oculus Go using the same workflow that you use for Gear VR. Another partner that we've worked with for years is Google. And I'm happy to say you'll be able to build for Google's standalone Daydream handset directly with the newly added 6 degree of freedom support for Daydream, making it super easy to develop and iterate for this platform as well. Unity has unparalleled support to broaden reach for your XR creations. We continue to build our partner ecosystem to bring you the platforms and technology that you need. With so many great platforms and with so many great partners and more than 25 platforms to choose from, Unity helps you connect with your audiences wherever they are, using whichever devices they know and love. All of this is coming in 2018.1. Now, 2018.1 will be released next month. Meanwhile, you can download and try the beta for yourself today, and we would all obviously welcome that feedback. Everything that you're going to see in this keynote, you can experience in this beta. But although there's a lot to like, and I heard giggling in the back, not everything in this keynote you can experience, but now I got your interest. There's a lot to like in 2018.1, but I think we've talked enough about it. It's time to show you some of the really cool new artist tools and also the rendering pipelines in action. Thank you.
Please welcome Director of Graphics, Natalia Tatarchuk.
Thank you, Brett. Hello. Next level rendering is our approach to unleash team creativity in an effort to produce amazing and beautiful visual experiences across all platforms. There are two key components when I think about this. First, it is about rendering technology. It is about being able to harness the power of platform diversity, performance of CPU and GPU, multi-core architecture, support for form factors like monster PCs, consoles, low-end mobiles. You've heard a lot about all the variety of devices that we service. Second, it is about artists' workflows. We want to give artists control to own the creation experience end-to-end with visual tools, working in the context of the production environment they're in and the production project that they're doing, owning results from creation point starting to the final debugging profiling through to ship. And that's a lot. Let's dive into the rendering technology aspects first. So of course, you just saw from Isabel, lots of different game experiences get created with Unity. From cinematic high-end experiences, rendering in real time in 3D, to 2D pixel art performers, to mobile games, AR, VR, and many, many more. And in fact, we don't even know what you guys will come up with, and that's the exciting part. And while Unity can deliver many experiences, what we wanted to do is to have its rendering engine evolve and offer both more power and more flexibility. Yup, we tried to do the impossible. So we went back to the drawing board with one goal in mind: to deliver one core rendering architecture, which is capable of serving the diverse outcomes without sacrificing performance or quality. This is not a small undertaking. In fact, this is a major conceptual shift for the way the Unity graphics has been working. We want our creators to access the power of modern hardware and GPUs. We want to offer a powerful and open real-time rendering engine, not a black box. We don't want you to have to learn millions and millions of lines of C++ code. I find that exciting, but you might not. It should be easily customizable, accessible through C# scripts and shaders. And we also want to make sure we set you up for success with out-of-the-box optimized templates for specific needs that you might have for a fast and easy start with the best-looking results. So how do we do that? The answer for us is the Scriptable Render Pipeline Architecture, or in short, SRP. This is our new architecture that allows extensive customizability of rendering. It provides an open API, and you can write your own renderer fairly easily. We actually give you two as a starting point out of the box for you to use immediately for your own projects as you wish, or to actually build from to create your own custom solution. And it has many strengths. It is highly configurable. You can perform rendering in Unity, as I mentioned, with C# scripts and shaders. It is lean. You can take only what you need. You don't need to bloat your rendering pipeline with things you don't care about. And most importantly, it is user-centric. It lives in user space. It's easy to debug, it's easy to extend, and easy to modify. Scriptable render pipeline is the overall architecture that gives us the framework and gives you the framework to write your own rendering pipeline. Now, we're giving two options, as I mentioned, for you to start from. And what we've done is we really look to cover different ends of the spectrum, and that's what you see here. The super high-end visual fidelity HD rendering pipeline, which is covering the really high fidelity experiences, all the way to lightweight rendering pipeline. The lightweight SRP is heavily optimized for performance, supports every Unity platform, from low-end mobile phones to high-end PC experiences, scaling with the user performance and the capability of platforms. The key thing about lightweight pipeline is it's super accessible. It's very friendly, it's easy to start for new users. We also made sure that we optimize the physically based rendering for the lightweight pipeline so that it can render with better performance on those low-end mobiles on AR and VR devices. We improved lighting fidelity. Everything is linear, predictable. And we gave you a ton of controls to make sure you have right attenuation parameters, fading, better options for lighting, so that you create beautiful things with this. Now, HD rendering, in contrast, is the pipeline that prioritizes stunning, high-fidelity visuals, of course, with performant results. What we made sure is that it's designed for GPU compute-capable consoles and PC hardware. So as you can see, Unity graphics is evolving. And it's evolving into a powerful, configurable, performant ecosystem. However, and I am an engineer, but it's not all about engineering. I firmly believe that beautiful graphics cannot come to life without the creative force, the artists. Only they are able to bring the spark of life to any algorithm that without their touch will just merely twinkle and fall on the ground. So I want you guys to hear from the demo team, which is a tour de force creative team that has been a core part of the evolving graphics frontier in Unity. Thank you.
Please welcome demo team producer Silvia Russia.
Hello, everyone. Hello, everyone. Unity's demo team consists of artists and programmers with many years of game development experience. We create content to drive advanced usage of the Unity engine and push the envelope of what is possible to achieve with our technology, both now and in the future. In a way, we are a user within the company, because we work in very close collaboration with Unity's R&D, all teams across R&D, and we are usually the first to try out new features and technologies as they are being developed, specifically around graphics. Our team is distributed. We are located in 7 different cities across Europe, and we have 7 different nationalities on the team. Cities and nationalities not necessarily coinciding. Our production environment is entirely virtual, with Unity being the creative platform where everyone's work gets pushed together. As a creative team, we have a distinct creative style, and we do care about the narratives. We do care about the aesthetics, specific themes that we want to explore that span beyond what is strictly speaking necessary for a technical demonstration. You've probably seen some of our work. Our short film, The Blacksmith, it supported the release of Unity 5, which premiered physically based shading in Unity and real-time global illumination in Unity. To this day, we continue to have a lot of fondness for Nordic-inspired themes. While we were creating our short film, Adam, we made use of all of the latest improvements and all of the latest advancements in Unity graphics that were available back in 2016 when it was released, including shading, lighting, post-processing, as well as the timeline feature. Neon was a small side project made almost just for fun, and it was created entirely with assets from the Unity Asset Store. It was very quick to prototype while still looking good due to the latest and most improved post-processing stack. And our latest project is Book of the Dead. This time, we are making an interactive experience. It is built on all of the rendering innovations that are coming with Unity in 2018. We will keep working on this project throughout the entire year as we continue to support and the constantly evolving and constantly improving graphics features within Unity. I will leave you with a brief look at Book of the Dead. Thank you.
Well, look at that. I didn't think you had it in you. Tell me more about this place. You spent nearly 90 years there.
What? No. No, not there. The forest is just the lobby. That's where the entrance is. I've been thinking, how do I remember all this? When did I make these memories? You need a brain to make memories.
Your brain is now remembering things that never happened to you, or to it. An enormous amount of neuron connections were formed since you came back. Decades worth of memory. And there's one more thing you need to do. Karen? Hey? Karen?
Yeah, sorry.
Are you all right?
Yes, I'm just tired.
Tell me, did you see any of the others?
Yes. I damn near fainted, even though he had told me about them.
You think that was one of them?
I know.
You're the only one who woke up, Karen. One out of tens of thousands. Why?
Please welcome Technical Director Lucas Meyer.
Hey everybody. I love watching that video. All real time, by the way. The rocks that you see behind me, they come from behind the house of my friend Ves in Stockholm. He went out with his camera and took a whole bunch of pictures of these rocks and all the pieces of wood and trees that you see. And he used a process called photogrammetry to turn these pictures into these textured 3D models. Photogrammetry is a technique that really enables small teams to create really high-fidelity assets in a really efficient way. And because we are in the business of solving hard problems so that you don't have to, we made a step-by-step guide to teach you and show you how you can do this at home yourself. You know, what kind of camera do you bring? How do you take these pictures? And you know, which buttons do you press to make, you know, where do you put the pictures in and get the model out? It's a whole bunch of software you need to use. We wrote some of it. It's really fun to do. If you're into that kind of stuff, I can highly recommend it. We also used a bunch of textures from Quixel's Megascans library. It's a library of really high-quality scan textures that are actually available on the Asset Store now, the ones that we used, so that not only we can use them, but you can use them too. In this next section, we're going to have a look at some of the graphics features in 2018.1 that were used to make this project look like the way it does. And to do that, let's get Natasha back on stage.
You guys thought you were done with me just saying a few words about SRP. Nope. So we're going to start from the high-definition pipeline. That is our cutting-edge rendering pipeline, which is now shipping in preview in 2018.1. And what makes HDRP cutting-edge is really the 5 key components that we use as pillars for the design and development of this core technology. It is physically accurate, which means that we use physically based rendering for our materials and physical light units for our lighting. It is unified because there is unified lighting and material response for opaques, transparents, decals, translucents, volumetrics. And also, baked GI matches runtime in terms of lighting, which means that it gives you predictable results under all lighting conditions, under all material responses. It's very configurable. You have tons of options to polish and create very specific content for your needs. And it really helps you achieve the results that you want while giving you a ton of debugging options to understand where you might have taken a wrong path along the way to help you to get to your final ship result. And of course, not the least, it is absolutely performant. Because we've spent a ton of time making sure that all of this unification consistency does not come at a cost to you. It is optimized for all of the rendering paths, suitable for the specific platforms that we're shipping HDRP on. Now let's take a deeper look at the components of what makes the scene we were looking at earlier beautiful. One of the key components is lighting. And making lighting behave consistently for all material types is very difficult. This is where many engines layer tons of hacks. Objects that might have looked right a second ago, when you move them from one corner to the next, let's say from a light area to the dark, may start glowing unexpectedly. Now, HDRP solves this by providing a fully linear, HDR, unified physically based lighting. Lots of words, a lot of buzz. But it doesn't matter what type of material or light types you use. That's the whole point of us doing it right. The results will be correct and consistent. Now, in this example, what you're seeing is Lucas is moving around the object around, and what you notice is it preserves the fidelity of lighting, the details, without creating a really unexpected response. So that's that consistency that I mentioned. In HD, what helps this is the light follows physical inverse square attenuation and uses physical light units, giving you ability to match real-world conditions. Most games tend to use very simple lights, spotlights, point lights, because that's really all they can afford for performance reasons. But we're changing that with HDRP as well. Let's take a look at a few area lights in our scene here. So what you're seeing here, Lucas just dropped a real-time line area light. This is one of the shapes that we're shipping. We're adding a few more shortly. And even though these lights are typically reserved for film and not seen frequently in real time, they really help bridge filmic lighting quality with real-time rendering. Now, in our case, they're also very performant. We made sure that in our optimized real-time implementation, the cost of an area light without shadows, like what you see here, is just twice of a regular vanilla spotlight. Now, HDRP gives you a lot of power to customize lighting, customize the visual results. But we mentioned we want you to own this end-to-end. And the way to do that, we're giving you power with a really extended selection of debug modes. Can we take a look at a couple?
Yeah, I have the new debug window open over here. I particularly like this mode here. It's the diffuse lighting. It's a mode that lets you see only the lighting in your scene, which is useful. For instance, what happens a lot is you need to figure out why something is too dark or too bright. And you want to know, like, well, is this my texture that's wrong, or if it's the lighting that's wrong? For instance, in this view, you can clearly also still see the area lights, the line lights that I placed. If you were wondering why that piece of grass was so bright, well, it's because of the lighting, which is with this view that you see. There's a whole bunch of other modes in here. Let me show you a few. I can, for instance, set it to my normals over here. And these set of debug tools, they really empower artists to investigate any kind of visual problem in their content that they might have. And the nice thing about it is that they don't only work in the editor, but they also work on the device. So when we run this project on our PlayStation, we can actually get these modes working on the PlayStation as well. Another cool thing about them is that they are very easily extendable. The demo team that made this project, one of the things they needed to do, because it's in a forest, they wanted to do something special with the amount of skylight that comes in. Because you have all these leaves high up in the tree, the leaves actually block the skylight from coming in, and they wanted to make a debug mode to visualize that. Took them about 8 lines of code, probably longer than it will take me to find it. Here we are. Oh, it's in material here.
He's learning.
I'm just faking it. Here we go.
And actually, this is a really good example. The whole point that we've just mentioned about SRP architecture is you can make it your own. The demo team found that they needed to add a better and more specific effect for outdoor environment. They extended it with scripts and shaders. They did essentially a compilation, a few shader compilation, a few hot reloads of scripts, and we're able to iterate very, very quickly on rendering algorithms, which is something that most of our graphics people are really unused to. We live in C++ world, typically. And so they extended their rendering pipeline specifically to add the volumetric sky occlusion feature. And actually, can we see what this brings to the party?
Yeah, I have them right here. Right here.
And so you can see why this was such a key, crucial feature. And in fact, we're shipping with it in 18.2. It really helps bring a lot of the environment richness to life with all of the details of how the foliage is grounded with this outdoor environment.
All right, there's a few more things in the scene that I would like to show. Let's take a look. So I have this area here from the sequence. And let's go to my post-processing settings. Post-processing settings. And let me tweak them a little bit. By the way, post-processing stack is out of beta in 2018.1. Now let me just create this sort of a different look. Now, you were always able to do this, but new in 2018.1, something that we added as we took it out of beta, is a new thing called volumes. Let me show you what they look like. You can go to the scene view, and you see these huge, ugly green boxes. And what they do is, the settings that I just applied, they only apply when the camera gets close to that box. You can control how soon the settings fade in and out. Let me show you what that looks like if I scrub a bit in the timeline here. If I go back here, you can see that now my changes don't apply. And when the camera gets in, they slowly apply 100%. And when I get out of here, they go out again. And the cool thing about these volumes is that they're actually not specific to post-processing settings at all. You can use these volumes to gradually fade, sort of like fade in and fade out settings of any kind of scripts that you might have.
And actually, for that matter, you saw it happening in timeline. And post-processing is integrated with Cinemachine and timeline. But what we also have with these volumes is the ability for you to craft the interactive experience. If you want to create a really intense moment in your game, when the player walks into a specific area, you use this volume, and bam, you can throw a really intense noir look with just a few settings. So it really lets you customize the experience very quickly.
All right, let me show you a few more things here while we're in this part of the scene. I have this tree over here. Let's zoom in a little bit. And you might have missed it in the sea of information that we had for you, but this guy over here, this is a decal on the tree. One or two users might have asked us in the past to add support for that, and I'm happy to say that they can finally sleep at night. Let's take a closer look at this tree itself. And turn on my selection wire. So this tree, if I zoom out, you can see the original topology it was authored at. Yeah, it's pretty relatively low res. But when I get closer to it, we're using tessellation and displacement to really add the detail only when we get closer. And this is what makes the tree still look so good when you get so up close. If you remember from the video, this is like that tree that the character put his hands on. Like there's amazing detail even when you get really close to it.
And it really helps amp up the fidelity of the overall experience, the high-quality visuals that we're really trying to let you create easily with HD render pipeline. In fact, one of the super nice things about the decal that Lucas just showed you is that, again, we're unifying it for both opaque and transparent. It takes in the proper lighting and correspondingly affects it at the end, just working correctly. Now, another important thing is we mentioned that we have a lot of material options for you to use in the HD render pipeline. But we also want to make it easier for you to craft and polish materials with that. So with that, in 2018.1, we're shipping shader graph with support for LT and HD pipelines, with tons of material options exposed. Now, all of these advanced material options actually can be additionally blended as layered materials, really allowing you to create complex surfaces, real-world believable surfaces. So for example, if we look in the back there, there's a nice brick mortar wall, and it has a complex merging of the brick, the mortar, the dirt, the dust, and that's what you do with the layered materials, using all of the options that are available in a default material. And in fact, Book of the Dead has a lot of really nice details that we can take a look at.
Yeah, so this is a shot that I really like. It's these leaves, and if I go around them, you can really see how the leaves sort of like, they both shadow each other, but you really see this light bleeding in when the light hits like the front of the leaf, and you could see it from the back. How is that
So this is, in fact, an example of translucent material. This is an option in the HD standard lit material. And what it does is it simulates how the light scatters through a backlit surface. Now, another thing that I really love in this level is this mysterious and rather strange amber creature.
Let me go to my friend here. Oh.
We get a special zoom-in look on that.
Yeah, you can see my friend here likes to keep an open mind. And he also has this, this sort of like weird orange stuff coming out of the wood. And this, I really like this material. Like if you sort of see how it responds to the light, I think it's subsurface scattering. I'm just reading up what this drop-down says. But let me use that drop-down to turn it on and off to see the amazing difference that this HD material provides.
And the way the light scatters from the surface is really a complex physical phenomena. Most of the approximations that physics and computer graphics has designed are really quite expensive to do in real time, and in fact, even for offline film. But we got several of them to run fast in HD. Subsurface scattering, of course, is what brings this material to life. You know, the sap that you're seeing, the ember that Lucas was pointing out, is where the light gets trapped. The light scatters, and you start accumulating a response in order to give you this nice, wonderful, volumetric, waxy look. Now, with HD, we allow you to do this with two options. We give you the game industry standard subsurface scattering Jimenez approach, which is highly optimized, but also For the first time in real time, we are providing a filmic technique for subsurface. Again, optimized for a specific rendering of real-time needs. We're giving an option for Disney Burley model for subsurface scattering with much higher quality results. Now, another major breakthrough that HD provides is multiple scattering approach for specular response. Well, I'm a graphics nerd, so of course, shader balls is a very important part of the presentation. Now, what's key about this is the first time in the industry for real time. And in fact, I'll tell you a secret. Only a couple of film offline renderers have this support as well. And what it means is even the roughest materials, as you see on the left corner over there, can actually look right in the dark corners. You see on the top, they go dark. On the bottom, they stay consistent. And along with multiple scattering, we also added options for iridescence and overcoat materials and clear coat that you see here. So here are a couple of really great examples. And in fact, let's see it live. They really help to provide you options to build high-end materials like enamels, iridized glass, metals, and other complex real-world surfaces. We bring you all kinds of shiny with HDRP. I can't get enough of the soap bubbles personally. That and my 2-year-old daughter who's watching this presentation is right now feeling particularly excited, I bet. Now, we are extending HDRP furthermore to add a few options for organic materials, like hair, skin, is a project done in HD using Yibing Zhang and the graphics team, which shows the power of an isotropic on hair, skin subsurface, and amazing BRDFs for cloth rendering. Now, let's go back to Book of the Dead. You know, with HD, Book of the Dead interactive experience is a great example of what a small team of amazing content creators can accomplish. But after people saw the Book of the Dead project, they kept coming up with two questions. One, isn't this just a movie? It looks like a trailer. And do you need a mega high-end PC with multiple graphics cards that can heat up my whole apartment to run it? Like, it seems really fancy. Well, the answer to both questions is no. And in fact, here you see a larger level from the Book of the Dead done with the same assets, with the same visual quality that is running a steady 30 FPS a second that Lucas is showing you on PlayStation 4 Pro. So he's interactive.
I'm actually playing right now with my PlayStation controller.
Exactly. And so it really demonstrates the benefits of Unity 2018 that allow you to craft high-end interactive experiences like this one that are optimized for modern consoles. And what's really powerful is the demo team started by developing on PC, which of course is easy. They didn't even need a dev kit. But they were able to use HD render pipeline to smoothly take it to the PlayStation 4 experience. And that's really the power that it gives you.
You know this tree? This cool sort of like octopus-looking tree? It's actually the tree next to the kindergarten where Wes takes his kids. He's kind of there. Look how it grows around the rocks.
Now, in fact, we want to use this demo to help others create and craft such stunning visual experiences. So with that, we're releasing the entire level with all of the assets on Asset Store in April. Personally, I can't get enough of this, and it really brings to life the anti-aliasing TAA technique here because it's just so smooth. Now,
do I have to stop?
Yeah, I'm sorry. I know, it's hard. I want to also give you guys a quick taste of something that we've been cooking that is coming soon that I'm extremely excited about. Now, we're going to take a step back for a second. Baking Lightmaps, which is a key component of creating lighting in many, many games today, has been a consistent frustration for artists. They take a long time, sometimes hours, especially if you want a shipping quality lightmap to really look at your level. And a level, to make matters worse, often needs several or even tens of lightmaps to make it look right. Frankly, it's just not fun to look at it, and not enough coffee. I mean, you can only take so many cups in an hour. Now, our CPU progressive light mapper made lots of headways to help it. But we can do better. And I'm happy to tell you about a new tool that we've created to help artists really get instantaneous feedback, which is our new GPU progressive light mapper. It is a real-time path tracer that is using real-time ray tracing on GPU to bake lighting in less than several seconds, and in fact, that is what Lucas is doing here, for the final ship quality light map. With GPU ray tracing, we can progressively bake, let's say, 2 million texels with about 100 million rays that are super sampled with 4 or 16 samples per ray in mere couple seconds. Honestly, having come from the world of hours baking light map, this is just absolutely insane.
So the environment I've opened here, you can see I'm in this sort of indoor thing. And the only place that the light comes from is like this hole in the roof, right? So most of the reason you still see anything is that that light bounces from wall to wall, sort of bounce light. Let me just turn off that bounce light for a second to see like what would be left if we didn't account for that. And let me just make that floor a bit exaggerated red. And again, as we care so much about the artist experience, we make sure that this tool also allows you to see only the lighting. And you can see that this is actually funny. The floor is white. Remember before how I told you can use these modes to figure out where something comes from? You can see here that the light hitting the floor is white. So the reason it was red before was because of the color of the material. But the reason that this things on the side and on the top are red, that's because the bounce light is hitting it. The light mapper, it is, let me turn on some colors again. It's also still progressive, so that's just a fancy word for saying that it only light maps what you're looking at, which gives this funny effect that you can sort of paint the level by looking at it. And it also works in much bigger environments. If I go to the outdoor environment that we have over here, you can see that this much larger environment is an area where the GPU light baking helps so much because, this would traditionally baking this would take so long. How many light maps is this, Natasha? This
level is about 6 1K light maps. Now, to light this, what we're actually computing here in real time is 4.4 billion rays with 4 samples per ray. And that's what you're seeing interactively refresh. And in fact, you can tweak your settings so you don't even notice when it actually updates the light map. We covered a lot of great features that we're shipping with our high-definition pipeline and our novel tools for artists, which is still in preview. Believe it or not, I had to take really hard cuts, and this is just skimming the surface. We wanted to tell you so much more about what's coming in 18.1, but time constraints. So really, please download it, try it out, engage with us, give us feedback. We want to hear your experiences. We've given you a lot of ideas of what's happening in the world of high-definition lighting and to make artist iteration faster. But of course, we also want to enable customer success across that entire giant gamut of the platforms that Unity runs on. And the Lightweight pipeline is our answer to that. Now, I want you guys to take a deeper look of what another really amazing content creator group was able to create with Lightweight pipeline. Thank you.
Please welcome Head of Cinematics, Adam Myhill, and producer for Made with Unity, Mike Wertherink.
Hi, everyone. Hi, everyone. So we wanted to test out some of these 2018 artist features and the new lightweight render pipeline. So Adam and I created a few scenes.
And we began where everybody begins, with the elusive, what is the vision? So let's make some storyboards. Let's make some cameras. Let's get an edit down, some scratch audio. Let's build an animatic. And let's work it there before it gets expensive. But then what? You abandon the animatic only to build it for real somewhere else? We didn't do that part. We experimented and we did the design straight in Unity. And I'm going to introduce a new feature, Cinemachine Storyboard. So this is Unity. This is timeline right here. This is an image on a camera clip. Basic storyboard. And you can see when we cross and we do a cut, we cut to another storyboard. And this is actually the same storyboard. You can see we've got an animation area here, so you can bring your storyboards to life. And when you have this, you're doing your timing, your edits right here. But because it's in timeline, you get this extra magic. Look at this functionality. I can take my clip and overlap it, and that becomes a dissolve. So you can breathe a lot of life into your animatics right here, but this is where the magic starts, because when it's all in here together, I can fade this down and I can go from an animatic to 3D. So instead of doing your 2D somewhere, when you want to go from 2D to 3D, you're already there. And you can mix and match these ideas. I've got a 3D scene built and this works fine. I want to try out a new idea. I can go from 3D to 2D and mix and match and start to craft your vision. Your timing is preserved from start to finish. Look at this. You can even take the camera here. I'm going to just mix this alpha in just a little bit. And you can tune your cameras to match your reference. And get your 3D cameras to perfectly match your storyboards. But it's more than just cameras. What we're doing is we're getting you right next to your reference. When you're building things and you have reference over here and then your game over there, if you want to get your reference to look like your game, you got to get them right next to each other. So we're putting the reference straight in. This is a Google map of Boston. And then here's a world behind. And Mike and I, we wanted to build a couple of blocks of Boston. So this is a punched in view. So we started gray boxing right over top of the image. And this is a big announcement. We did this in Editor. We were modeling gray boxing in Editor, and we were doing that with ProBuilder. And ProBuilder is part of 2018.1. Mike's going to tell you all about it.
So like Adam said, we're gray boxing with ProBuilder. I'm a huge fan. I've been using it for years. So we've got our small gameplay area that we mocked up. And from the concept stage, we start actually being able to test out ideas, test out interactions. And as the final art starts coming in, we can very rapidly go from gray box to your final art. Now, we didn't just use ProBuilder for gray boxing the environment. We actually used it to start gray boxing interactions with the world. So here we have these characters that are in this intersection. We thought it'd be cool if maybe a car came and took out some monsters and they dodged it.
And you just animated that really quickly.
So you can see there's a couple keyframes I laid out in timeline here. So it took a couple minutes to mock up this idea. But because it's ProBuilder, I can just grab the car and grab some edges and make my car look a little more car-like.
And we're modeling.
We're modeling live on timeline as we're doing these things. Being able to iterate and try out ideas really quickly is super powerful. Now, that's kind of, it's all good, but that car doesn't really match our look. So one of the new awesome features that we have is kind of a part of the exclusive collaboration we have with Autodesk, where we can now export right from timeline. So I've grayboxed this idea, and I can export it out to my DCC tools and keep all of the timing, which is exactly what we did. So I sent this out, exported it out, sent it to the artists, and an artist who is much better at modeling than I am actually created a car that looks like a car. And they added some suspension, some wheels turning, some simulation, and they created this cool result. I brought it back into Unity. I'll just unmute those tracks. And you can see the timing and the position, everything is all kept right from our original idea. Now, having this kind of precision placement and trying out ideas is so important to your artist to be able to actually get that final look.
And you're running the simulation in Max, which is really good at it, but you get it back super quickly.
Exactly. Now, something else that artists are always super picky about is being able to create custom materials. And here we have an animated billboard up here that is actually being done with our new shader graph that Natasha mentioned earlier. So this is the shader graph, and it's all integrated, built into 2018. And here we just split the UV channel. So we're just animating the X of the UV. And you can preview objects, bring in custom objects. No code. It's all linear or visual node editing and visual debugging. So you can very quickly create your own custom materials. This is extremely powerful workflows with 2018.
We have a shader graph. So as you move forward in your project and you get to the end, when you're color grading, doing lighting, pulling everything together, that last 10% can feel like another 90%. And what I've got here is this is an image that I like. I like the colors. Look at the warm and the gradient, and look, there's that kind of purpley color in the shadows. So because we get the reference right over top of the image, you can work with them so closely together. So in addition to the alpha, which I showed you before, we have this thing called split view. And what that does is it splits your overlay image to your game. And you can see the game needs a fair bit of work. I want it to look like this, but it's currently looking like this. And to help you with this, there's this button here, the Waveform Monitor. It's just right at the very bottom. And what this does is this opens a Waveform Editor. And this shows you representation of all the colors in the scene. You can see the line down the middle. Watch as I wipe. This moves. Now, to some of you, this looks like clown barf, a sea of colors, doesn't make any sense. To the artists, the color graders, the art directors, you know that this is a film-grade professional workflow. And what you do is you tune your game's lighting, materials, to match this. And I'm going to have a quick go. So I'm going to increase the sun size a little bit. And then that's got us a lot closer. Look at this. You can wipe and you can see I need a little bit more color in the sun. So I'm just going to double click that. Here's my color. Add a little bit more. I'm going to do one more thing. I think the shadows are a little bit out. I could use a little bit more purple, so why don't we just turn some color grading on? And you can see in seconds, okay, I rehearsed this before, but you can see that in no time at all, you're getting your game to look like your reference. Let me just do one more of this, the sky color. This is going to control the shadows of the game. I'm going to just wipe this over a little bit more. And being able to overlay your visual target with your game. And you can see I just need a little bit more purple in my day lighting. So I'm just going to hit that. And Scoogy, close enough.
Ship it.
Chip in. So I want to tie all this together. This is lightweight. This is a beautiful renderer which works on the most platforms that are out there. And look at the features we talked about today. We've got Storyboard, Pro Builder, the DCC round trip, the shader graph, and then the color grading. Like, any of these tools individually is powerful, but together, you can align your game with your vision. You've got everything together, and all of this is in Unity 2018.1. Thank you.
Thank you.
Please welcome Unity's co-founder and Chief Technology Officer, Joakim Ante.
Thank you. Since I was in high school, which is when we wrote the first couple lines of code of Unity, we haven't really changed the core foundation pieces on top of which Unity is built. And today, I want to talk to you about how we're going to evolve Unity. So everything we're building is based on some principles and goals. And that's what I want to talk to you about today. So when I'm working on a game, there are times where I just need to sit around and wait. And when that happens, I can feel a little bit of anger inside of me building. And we don't want that. No. I want everyone to be really happy when making computer games. This is what we love to do. We should always have fun doing it. So we have a very specific goal in mind. We want to make it so that any change to content in Unity takes less than 500 milliseconds. Why 500 milliseconds? 500 milliseconds feels instant. Google figured this out. When you search with Google, you never wait for longer than 500 milliseconds. So 500 milliseconds from making a change to a single C# file in a large project folder. 500 milliseconds to changing an FBX file to seeing it take effect on the target device. That's our goal. Another really important idea is that we think of ourselves as your engine team. But what does that really mean? So to me, it means that we work in close collaborations on productions using Unity. And we did this while, for example, developing the entity component system. Together with our friends at Nordios, we created a tech demo of a large battle simulation to really show off what you can do with the entity component system. And both of the teams learned a lot from that experience, and it was really quite amazing. And it had a huge impact on the final system. And we want to do a lot more of that. But to do that, we need a really solid foundation. And we need the ability to deliver changes only to the parts that we're working on, so that you can update to the latest version of a particular feature in Unity, confident that all the other parts of Unity stay exactly the same. And that's packages. Then this is probably my favorite one. This concept is performance by default. So first of all, what is performance really? So I'll start with an example. My friend Mike Acton. He's probably one of the best engineers for writing high-performance game code in the world. And when he writes code, he knows exactly what hardware he's targeting. And he lays out his data specifically for that hardware. And he writes code specifically for the platform. And he makes it run the most optimal way. And so that's what we define as performance. And when we say performance by default, our aim is that we want to enable you to write code like that by default, similar performance levels. So the most important thing about performance is data layout. And that's why we built the Entity Component System. The Entity Component System is a new way of writing game code and engine code that makes it easy and automatic to access your data in the optimal way for the particular hardware you're targeting, all using simple code. Now, individual CPU core clock speed is not getting any faster anymore. But more and more cores are being added. So if you want to stay competitive making the best games, you need to take advantage of multi-core hardware. The problem is, multithreading is inherently difficult. So we built the C# job system to solve the fundamental complexity of writing multi-threaded game code. We make it safe and we make it easy. The burst compiler is specifically made to write C# jobs, to compile C# jobs. It is about generating the optimal machine code for the different target platforms. And we're making it very easy to take advantage of all the instructions on the CPU. So as a whole, when you combine all of these things together, you can get on the order of 100x speedups. That is the Entity Component System. Right. So by combining the Entity Component System, C# jobs, and the burst compiler, you can get these speedups. Another one is connected games. Connected games is super important for Unity. I believe that in the future, almost all games that are successful will have some form of networking built into them. And so we think that Unity must become the best game engine to create networked games. And I also think no one has really solved this problem right in any game engine so far. And I think the problem is that game engines always look at this problem as, oh, we take this one networking architecture, and then we will just fit that to all games. But the reality is that different types of games are really fundamentally different from a networking perspective. The way you network a real-time strategy game and a first-person shooter are simply different. So we're acknowledging that, and we're building the networking architecture really into the core now, and we're making it so that you can choose which networking architecture you want to go for. If you want to go for an RTS game, a fighting game, or a first-person shooter. Now, we want to make it really, really easy. So when you're writing game code, we want to make it so that writing network code comes by default, so that you don't have to think much about that with a single way of writing code. But ultimately, so all of these changes, they are really a big change in how you can write game code. And ultimately, the only one who can really convince you that this is a good way to do things is you. You trying it on a real project by yourself. And so our aim is to make it really easy to try it out. If you have an existing project, our goal is to make it so that in 30 minutes, you can take a single mono behavior with existing Unity game code and convert it to the Entity Component System and have a good experience optimizing your code. All of this new technology you can adopt piece by piece. So you choose if and when you want to use this tech inside of Unity. So everything we're building is based on these principles and goals. Some of those you can see clearly in the entity component systems. Others are goals we're only starting on now. So how can you get involved? Today, we're making the entity component system available as a preview. It isn't available for production yet. This is for the adventurous ones, those who want to make games that were impossible to make before. We also have a tech demo showing a large battle simulation, and we're making that project available to you as well today. So this is the very beginning of a journey of evolving Unity, and we want to invite you to take a look and give us feedback on that very early on, to come along with us on that journey. So thank you.
Please welcome Director of Platforms, Ralph Howard.
Hi. Hi, everyone. That was our best high five to date. And you know what? That high five is really well deserved. Because I've been one of those people that have been pioneering and trying that build out. Actually, I was lucky. I got to try it out together with Joakim. And ECS and Burst are really game changers. But what Joakim was talking about was experience or performance for experiences at large scale. What Joakim was talking about was the big. What I'm going to talk to you about is the small. Now, I would almost do like, and have the fairy dust come out of my hands, but when you develop these small footprint, light experiences that can be delivered truly anywhere, there are two fundamental components that matter. One of them is size, the other one is speed. Now, we want to give you the ability to develop anything you can envision. And you told us you want to build light and fast experiences. To reach the world's next billion devices, your apps need to be light and fast. When thinking about entry-level mobile phones, wearables, IoT, or even the web, your experiences need to be light and fast. And we want to enable you to do that and create these experiences using the Unity editor, the tooling, the extensibility of the editor, and bring that to that world. So we're expanding Unity to support the development of smaller, lighter, and faster experiences. To do this, we've created a brand new, highly modular architecture, a new set of specifically designed components that you can use using the Unity editor. You can create these components in the Unity editor. Now, this results in a smaller, portable runtime that can run natively on lightweight devices, but something I'm very excited about and always have been very excited about is the web. So let's talk a little bit about that runtime on the web. For web-based deployment, the file size of our compressed core runtime is 72 kilobytes. So let me, hold on. Let me put that in a frame of reference and then tease it out for you. So a song you stream off the internet on average is 4 megabytes. A web page on average is 2.4 megabytes. A desktop icon, just the icon, the file size of that is 500 kilobytes, and we're doing 72 kilobytes. That's cool, right? But it's not just about that small runtime. We're combining it with optimization through our asset pipeline to create small assets, resulting into small file size. So the data-driven architecture, the exact same data-driven architecture that Joakim just spoke about, combined with those small assets, that leads to fast delivery and startup times. This fundamentally expands what you can build with Unity, all within the editor that you already know, with the assets you already have. Unity will take care of packaging and compressing your assets for you. Now, there's many use cases for such a runtime, and I'm going to ask you to let your imagination run wild, but today I want to talk about two of them: playable ads and games in messaging apps. So let's talk about the first type, playable ads. Playable ads are a demo format for ads that allows people to try your game without actually downloading it. Now, since your games truly are fun and engaging, and I know this, I actually get to play them. I have 3 small boys that play these games and point at the screen when the Unity logo pops up and says, "Look, Daddy, your work. It's beautiful to experience what all of you are creating." But to get people to actually download and play them, they need to try it. They need to experience them. And today, it's really hard to provide that experience. To be fair, you know, it's a lot of work to build them. They're too big. And quite frankly, there's no tooling to build these things. But let me demonstrate what we can do now. So our friends at SpaceApe, they've shared with us their assets for their game Fastlane. We wanted to use something to show the effects of what our small runtime, that data-driven architecture, and that asset pipeline for compression could do for you. Now, I always shake a lot when I get on stage, so I have asked Lucas to actually come and demo together with me. Now, Lucas, before you start, I want to actually pull everyone's attention to something before we start doing this. So Lucas is going to hit that icon for Fastlane. But what I want you to pay most attention on is actually the time from the click to playing the game. How about it, Lucas?
Are you ready for it?
I'm ready.
You're not paying attention.
Oh, I should pay attention. Let's watch all of that. Play. How about you play a bit, Lucas?
Okay.
So this game is actually using HTML5 and Canvas. Now, why? Well, Canvas is the ultimate way to actually deliver to a wide variety of devices and rendering 2D games. It allows you to target all different devices of every end of the scale, from low-end to high-end mobile. Now, that was a cool example. Lucas, should we try the other one?
Sure. Here we go.
Let's go and try Empires and Puzzles by Small Giant Games, also a playable.
So was that already cached, or did that download while I clicked it?
Well, I hope it just downloaded. It would support the statistics we have on that and all the measurements that we do every day. So if you look at this game, it's a lot more rich, right? There's more animation. You can hear sounds. You can hear the music. You can see the animation in the characters. But hopefully, while doing that, you also noticed the really fast download and start time for this application. How's the game? You're having fun?
Yeah, I'll be here for a while.
Well, actually, allow me to go a little bit more in depth, because I think those 2 demos, they went by really fast, the actual example. So, Lucas, thank you. I want to dive in a little bit in the numbers. So, that first playable ad, Fastlane, we had 2 versions of that. One version built without Unity, and one version built with Unity. So the version without Unity was 2.6 megabytes. That's the runtime, all the assets, everything downloading. The other is actually built with our compression techniques and our new runtime and this data-driven architecture, and it's actually less than 800 kilobytes. Oh, that's cool, right? But there's another number that's important for this. And it's actually, if we go to the next slide here, cold load time. The cold load time of the non-Unity version of this playable ad was 2.7 seconds. Now, what's cold load time? It's getting the game from the internet, downloading it, putting it on the device, starting it up, and actually the player running it. In this case, for the non-Unity version, that was 2.7 seconds. In the Unity version of this, with this newer, smaller runtime, it took 1.3 seconds. So 1.3 seconds from getting it from the internet and playing. Now, all of this gives your players a better experience. These are the people that are going to try your game. It gives them a better experience. But why? Well, exactly what Joakim said. Nobody wants to sit there and wait for something to load. So faster is always better there. But these properties, the size and the load time, they're also critical for building games in messaging apps. We're expanding the base set of components and the runtime, the same runtime that I just showed you, so you can deploy rich and fast games in messaging apps. Now, I'm going to tease you a little bit here. Currently, we're working with a number of developers in closed alpha, but we are bringing this to you in 2018. Now, a couple of times you heard already, we're your engine team. We are your engine team. No matter where you want to go, no matter what you want to build, no matter if it's big or small, we'll help you get there. Thank you all.
So at this moment, I'm the only thing between you and a drink. So I'm going to make this quick and try to get right to the point. I'm going to start with a word. The word's amazed. And what am I amazed by? A few short years ago, Unity developers, all of you, were creating a tiny fraction of the world's games and interactive experiences. And what I showed you earlier, you're now making more than half of the world's games. You're making two-thirds of the world's AR and VR. That is absolutely amazing. And as I mentioned, this notion that you're an industry unto yourselves, one of the top employers in the world are you. You're hiring more people than entire industry sectors because you as developers are changing the world. You're creating, you're innovating, and you're changing the environment for all the cool things that come next. And that's because of the craft and the commitment you have. Second word I want to talk about is pride. I am seriously lucky and proud to stand before and after the presentations you just saw. Now, there's Brett clicking his heels together and saying, nested prefabs, it's coming. But what a roadmap. Natasha and Natalia, she goes by both. What she showed with the Scriptable Render pipeline, high def, low def, it changes everything. You can make achingly beautiful products. And what we saw from Joakim, our standard once upon a time was to make the best game engine relative to our competition. Make no mistake, Joakim's ambition is to make the best game engine theoretically possible, limited by things like the speed of light compute. It's unbelievable what the ambition is. And Ralph showed you something that we all know. Small is beautiful. Small is fast. Small changes the devices you can reach, the experiences you can create, and the success you can have. So thank you for attending our keynote presentation here at GDC in 2018. I hope you'll join me, or several of us actually, upstairs for a drink. And in signing off, got an interesting, cute video to show you for a couple minutes, and then it's off to the races. Thank you, everyone.
Rolling. We're speed.
Could you scooch a little to your right?
Me? Yeah, just a little right.
Sure. A little bit left.
Oh, wow. Am I okay now? I don't know what I'm doing. I get excited and then I do this.
So we'll start with an easy question. What is your name and what is your role here at Unity?
John Riccatello, and I hang out a lot.
I refrain from saying I'm the CMO because it sounds a bit up its own arse.
So what brought you to the United States, to America?
A large wooden boat from Plymouth.
What'd you have for breakfast?
I had overnight oats.
I can't get into those.
You know what? I don't really dig it.
I started to hack.
Do you have any good stories from that time?
Yeah, but it's stuff that I can talk about.
You can put all kinds of interpretation into that.
Is there anything I'm supposed to be doing other than answering these questions?
No, you're doing perfect.
Okay.
Okay, how technical do you want me to get?
Technical.
Can you repeat the question again? We have the.
Sounds like a huge job.
Yes?
That will give Unity the longevity.
Say it again, but say longevity.
Longevity. Okay, yeah, longevity.
Did I just crush your... Hey, my mic is slipping.
What? Nested prefabs.
When are you going to get nested prefabs?
I have a T-shirt. I made a T-shirt that said "Nested Prefabs?" ?
I don't think that's what the users want to hear.
It's just like, we're literally in the middle of an icy void on a ball of rock. Here we go.
It's all being edited, right? So I'm just not going to worry about it.
We both look a mess, but we couldn't